Today's AI is, well, it's pretty incredible, right? It can write poetry, create art that'll blow your mind, it can even write computer code. But what if I told you that for all that power, they're missing something really fundamental about how reality actually works? Today, we're going to dig into a framework that's looking to change all of that by teaching AI how to decompose reality itself.
So, what if the key to a truly smarter AI wasn't just about building bigger and bigger digital brains? What if it was about teaching them to see the world in layers, to take apart the signals all around us, from light waves to brainwaves, and then compose a much deeper intelligence from those basic fundamental parts?
And that brings us to the core problem, what we can call the AI chasm. You see, right now, AI systems have this kind of split personality. They've become absolutely fantastic at one of two things, either raw perception or abstract reasoning. But they really struggle to do both of those things together in a deep, unified way.
Think about it like this. Perception is like recognizing the notes on a page. Yep, that's a C#. It's fast, it's reactive, it's all about patterns. Reasoning, on the other hand, is like composing a whole symphony. That requires deep, structured thought, understanding the rules, and planning way ahead. Today's AI is amazing at that first part, but bridging that huge gap to true composition, that's the grand challenge.
So, how do we even begin to build that bridge? Well, the first part of the solution is a completely new way for AI to perceive the world. It's a framework that's designed not just to see, but to see in layers, by literally breaking down reality.
This slide shows the idea perfectly. Just take a look at this leopard. The framework we're talking about can take this one single image and pull it apart into its essential pieces. You've got the low-frequency forest, that's the overall pose and shape. Then you have the mid-frequency trees, the boundaries and contours. And finally, the high-frequency leaves, all the fine textures and sharp edges.
Okay, so this whole idea has a name. It's called the Universal Signal Decomposition Framework, or USDF for short. The absolute genius of it is that it treats any kind of data, an image, a financial trend, even a brainwave, as a signal. Then it breaks that signal down into these layers, from the low-frequency, big picture, all the way down to the high-frequency, tiny details. And this is where you really see the power you get from that decomposition. Because these layers are separate, you can actually control them. You can grab the low-frequency pose from a cat, combine it with the mid-frequency body shape of a dog, and then slap on the high-frequency texture of a tiger to create a totally new, completely coherent image. You're not just mixing pictures here, you're composing reality from its building blocks.
And let's be super clear, this is not just some cool trick for images. The U in USDF stands for universal. The exact same principle, separating signals into low, mid, and high frequencies, can be used on language. You can break a document down into its main topic, its sentence structure, and its specific word choice. Or you can do it with financial data, separating out the huge macro trends from the noisy day-to-day fluctuations. It's a fundamental principle for understanding any complex system.
But look, perception is only half the battle, right? Now we've got to explore the second piece of this puzzle, an architecture built not just for seeing, but for actually thinking. Okay, get ready for this one. Meet GSARAVE. Yeah, I know, it's a total mouthful. But you can just think of it as the reasoning engine. It's an advanced AI architecture designed specifically for deep, structured thought. It can even adapt and improve itself over time, all while making sure it operates safely within a set of rules. So let's break that crazy name down. Deep hierarchical representation just means it can understand ideas at lots of different levels of abstraction. Its recursive reasoning engine lets it kind of chew on a problem, thinking about it over and over to refine its answer. Self-adaptive evolution means it can actually improve its own internal wiring. And finally, principled governance. Think of these as safety rails that prevent the AI from just making stuff up, a problem we usually call hallucination. So we've got the layered perception with USDF, and we've got the deep reasoning with GSAE. The real breakthrough, the unified intelligence, happens when you put them together. So the big question is, how do you actually pull that off? How do you combine these two incredibly powerful but very different ideas to create something that's way more than just the sum of its parts?
Well, you don't just bolt them together. In the unified USDF GSA framework, the layered perception from USDF becomes the direct input for the GSA reasoning engine. So the reasoning engine isn't just looking at a flat picture anymore. It's getting this rich, multi-layered model of reality. It can reason about the forest, the trees, and the leaves all at the same time. This grounds its thinking in the real world, and that dramatically reduces the risk of hallucination.
And the result of this integration is just a massive leap in what we might call the AI's depth of thought. Because it can analyze the big picture, the medium details, and the finest points all at once, its reasoning power is basically multiplied. It can understand the short, mid, and long-term consequences of a problem all at the same time.
Now, I know this might all sound very abstract, but it has some absolutely stunning real-world applications. So let's look at one that honestly feels like it's been pulled straight out of science fiction, creating a truly unbreakable lock that uses only your thoughts as the key.
This is Project Encephalon. It's a real-time, high-security authentication system. But instead of a password or fingerprint, it uses your past thought, a complex mental image that's totally unique to you. It's a key that can't be seen, can't be stolen, and you can change it whenever you want. And yeah, it's powered by this brand new approach to AI.
So how on earth does it work? Well, it all starts at layer 0. The system uses USDF to take your raw brain signals from an EEG and, you guessed it, decompose them into all those different frequency bands. It separates the signal of your intentional past thought from all the background noise of your brain. And that incredibly clean, layered signal becomes the rock-solid foundation for all the other security checks, making the whole system just vastly more accurate.
And the results are, well, they're astonishing. Just using that USDF perception layer by itself, the system hit a true acceptance rate of 99.7%. Think about that for a second. It correctly identifies the right person based only on their thoughts almost perfectly every single time. But for a lock, this is the number that really matters. The false acceptance rate is just 0.01%. That means the chance of it letting the wrong person in is practically zero. It just blows other state-of-the-art biometric systems out of the water.
Okay, now this is where it gets really exciting. The researchers are projecting that by integrating the full unified USDF GSAA framework, the accuracy for even more complex mental tasks, like detecting if a specific memory is even there, is projected to jump to an incredible 91.2%. This just goes to show how the full synthesis takes an already unbreakable system and makes it even stronger and smarter.
So let's just quickly recap our journey here. We started with AI's split personality problem. We saw how USDF gives it layered perception, letting it see the world with all its rich detail, like the forest, the trees, and the leaves. Then we brought in GSAE as the powerful reasoning engine, and we saw how putting them together in the USDF GSAE framework creates this new, holistic intelligence with some absolutely stunning real-world potential.
And that really brings us to our final thought. This isn't just about building a better security system or making cool images. This is about a fundamental shift in how an AI can understand the world. So the question I want to leave you with is this. If an AI can finally perceive and reason in this deeply unified way, what long-standing, fundamental challenges in science, in medicine, in our society finally become solvable?